Okay, this is my pocket. Okay, now we're ready. Thank you so much for coming, everyone. Okay, so what time is it? A couple of minutes. Okay, we'll get started. So just want to acknowledge that we're on Kaurna land and we pay our respect to elders past and present and wherever you're located today, because we have a lot of people online as well. I also want to acknowledge that these workshops have been made possible by a PERSA grant, so thank you to them, and the hard work of Ollie and the platform team, Andy and Seb from Gaia, and Elizabeth Tarenko, who is the Collaboraculture Project Coordinator. So we want to thank you for your time, for taking your time out of your day to start this journey with us. We're coming together to look at vineyards differently, not as soil and leaf and grapes, mulch, rain, tractors and sweat, but we're going to set aside space to reimagine vineyards, drawing out the mappable points and lines running through them. We're going to learn each other's names for these elements so that we can sow the seeds of a standardized data model. As we move through this journey of 6 workshops, we're going to do all of this and we're going to inspire each other as we realise the potential these resources hold for vineyards of soils and tractors. If you haven't taken the time to read the discussion paper we shared, and it's on the collaboraculture.com website, please do. The author is John Byant. John is one of the best open source GIS community mobilisers we have here in Australia, and we're very fortunate to have him as a leading thinker and support for all of us as we navigate this topic. He'll close the session with context and direction to take us into the next of these workshops. Also today you'll hear from Emily Eros from Shared Streets and Fiona Duncan from Bitwise Agronomy, 2 very impressive women, and this is going to be a fantastic session. Shared Streets help people reimagine how cities are thought about, designed and used, and they've been a real inspiration for this project. By creating a shared digital language for the street, they're producing key infrastructure of the digital age, and we're very excited to have Emily, the public sector tech lead at the Open Transport Partnership and Shared Streets, here to talk to us today. She's also going to discuss why open standards are important and the key learnings that we can take from their efforts of mapping the world's cities as we set out to map the world's vineyards. And in the viticulture world, for visionary thinking and database insight and action, you'd be hard-pressed to find anyone to surpass Bitwise Agronomy founder and CEO Fiona. Bitwise Agronomy's GreenView app uses machine learning and data from, say, a tractor-mounted camera to create a Google Street View of vineyards that can be used for monitoring and analysis over time. So as today's workshop progresses, I'm going to invite you to think about the wealth of information that Fiona's app is collecting, the knowledge and insight that can be gained from these kinds of technologies, and then think about your own property. How do we map all of that stuff back onto our own vineyards? How do we make sense of it? How do we integrate it with other data? How do we share it, make it useful, and how do we put it to work? This is a fundamental challenge for the viticulture industry and ag tech right now. And it's the problem we're all here to start solving together to make maps and data really work for all of us. So without further ado, I'm going to hand over to Emily. By the magic of someone else.
All right, just give me a second and I will set up the screen share. All right, can I get a head nod that you can see my screen? Okay, perfect. Well, first of all, thank you all for having me. Like Lindsay mentioned, I normally work with city governments, and so it's not often that I get to come and speak to a completely different audience. And it's really exciting to have a chance to speak with folks in the wine industry. So my name is Emily Eros, and I work for an organization called Shared Streets. And what we do is we're a nonprofit, and we build open source software and digital tools to help city governments try to figure out where their streets are, what's happening on them, and be able to exchange information so that they can understand and be able to manage them better. So we're a tech nonprofit, so we work with technology, we care about cities, we like maps, but really what we're trying to do is help cities understand what's going on so that they can make their streets more livable for all of us. And data is really important for this. We've seen so many changes in transportation over the past few years where we have scooters, rideshare, e-commerce taking off, And all of these new devices on our streets, many of which are kind of emitting geographic location. And so it's really never been more important for cities to be able to work with maps, understand where things are going on, and manage all of these different modes on their streets. But what we found is that they run into a lot of blockers, often around maps. So every city has their own understanding of where their streets are, and then every company like Google, Uber, scooter companies also have their own maps, and it becomes really difficult to share information across them. So what we try to do is build a shared language to make it easier to share information and easier to work with it. So kind of trying to solve these map problems to start with. And also just helping cities organize the data that they do get. So sometimes the problem is that cities, there's private modes of transportation happening. Cities want to understand it. Sometimes they don't have data from Lyft, Uber, scooters, et cetera. But sometimes the problem is that they do have data, but they can't make any sense of it. So the map on the screen there is a representation of what a city gets when they ask a scooter company for information about where trips are happening and they want to figure out which streets are being used. You can see a bunch of dots. If you stand back and squint, you might be able to make some sense of it, but it really doesn't tell you an awful lot. So we have all this data, we don't tend to have a lot of information. And so what we found is that all of these individual cities, they either have to have very specialized tools, they have to hire a data scientist, or they have to contract with a private company to try to turn their information into something meaningful. And it's a real opportunity for, instead of a city and a private company to be able to work together, we have to have all these companies in the middle that sort of own the map and control who gets access to it. So these are the kind of things that we're concerned about and trying to build solutions for. So here's a concrete example of the type of stuff that we work on. This is kind of the previous slide of all that mess of data, but turned into something more organized. This is data from Lyft and Uber about where their pickups and drop-offs are happening on the side of a street. And we've partnered with them to share it out to a number of cities. This is Washington, DC. Instead of something really messy, we've been able to kind of organize it, link it back to the street, and you can start to see hotspots of where activity is happening. And so that's something that Washington, DC has used to put in some pickup and drop-off zones in nightlife areas at certain times of the day and evening. It's something that the city of Toronto has used to notice that there were pickups and drop-offs happening in bike lanes. And so they're starting to think about how they can put in some barriers or more enforcement to protect cyclists. So having this information is something that a city can use to really change what's happening and try to improve quality of life for people. And that's made possible by being able to describe the street in a certain way, be able to exchange data, and just be able to visualize and work with it. So the tools that we build for things like this are free, they're open, they can be repurposed. We're not really trying to sell anybody anything, we're just trying to kind of unblock them. So that's the kind of thing that we do. Mostly what I've been working on the past year is data standards for the curb, which may seem quite different from vineyards, but I'll kind of talk through what we do and you'll start to see some connections here. So the problem that came up is that the way that people move around a city has changed a lot with all these new modes of transportation. The way that we shop has changed, the way that we dine and order food has changed. And so cities in the US and I think around the world are starting to see people really fighting and becoming contentious over access to the side of the street. Instead of just having parking spaces, people want to be able to pick up and drop off passengers, goods, and other things. And it's made streets a little bit more chaotic in a lot of places. And so cities have been considering how they could reevaluate space and maybe change things up. Companies are looking for better ways to navigate and just make more efficient deliveries. Passenger vehicles would probably like to be able to navigate and pay for space. And so there's a lot of things we can do to try to make this better, but we can't really do any of that until we have a map of where we're starting from. So how are allocations currently? How can we envision them differently in the future? And it turns out that's a lot more difficult to map than it sounds. So along the street, you can go out and you'll see all of these different parking signs, fire hydrants, paint. There's all kinds of different markers that tell you what you can do. And that's pretty straightforward to map. But when you do, you just sort of end up with a bunch of dots along a line. And I can look at that and say, okay, you've mapped it, but I still can't tell if I can park here or not. So, we need to find a way to get something more meaningful out of it. And what we're really trying to represent is something a lot harder. Parking rules are hard because they're these invisible laws that apply to the side of a street at different days and times to different people. There's often kind of stacks of them. So you might have loading zones, cleaning zones. We have snow emergency zones here. And it's much more complicated than just a bunch of signposts. So what we noticed is that individual cities were all trying to solve this in their own way and getting stuck. And there were private companies coming up who were able to solve the problem, but they were coming in and saying, you know, pay us, we'll map your city. You'll be able to get access through this platform to what's going on. But behind the scenes, what happened is this company owned the data, controlled who had access to it, resold it. And so the city was kind of paying in perpetuity to understand their own laws. And parking rules are, they're public law, and we feel like they should be public record. They should be something that cities can have control over and not just be locked into something. So we were trying to build a common language for this. The easy part is we can all agree on ways to call something a loading zone. The hard part is how do we represent these kind of invisible rules? So we started building a shared language, a data standard for the curb. Here's what it looks like. I won't get into it too much, but it kind of has three essential things in it. You can take any sort of parking sign and turn it into this. We call it curb LR. There's some geometry information where there's physical coordinates that you can drop onto a map. There's more detailed location information. So this is a way of saying, you know, I'm talking about Lakeshore Drive from 51 to 65 meters on the left side. And there's an ID that we can use to link that between maps so that if someone else has a slightly different base map, they're able to generate this ID as kind of a Rosetta Stone. So that's sort of a way that we can say, I'm talking about a segment of a street. And then there's sort of the who, what, when, where, why. So in this case, I'm saying what is allowed or not allowed here, by whom, at what time is payment required. If I've lost anybody here, vineyards are a similar problem where you kind of have these lines of rows, and you may want to be able to say, you know, I'm talking about these 20 meters of vines, and I want to be able to say what grape variety it is, when it was planted, that kind of information, or identify a fence post or track where I've put fertilizer. So it's the same sort of thing where you need to be able to describe the location along a line and then start to add some more nuance on top of it. The benefits of having a standard are phenomenal. So this is standardized curb data for Portland, Oregon. And what I've done is just kind of built a quick visualization that takes what was a chaos of dots and turns it into something a lot more meaningful. So this shows for 12 p.m. on a Monday, what is allowed on different sections of streets. So where can I park? Where can I load? What is a bus stop? And this is something that any city could take their data and plug into. So instead of having to reinvent the wheel and build their own analysis tool or their own visualization or their own map, they could take what I've already done and just plug their own data into it. They don't necessarily have to make it public, but it means that not every city needs to hire somebody to build a custom app, which is probably a situation that's relatable for a lot of folks here. So it opens up possibilities to share information and collaborate with other folks outside of a city, share it with the public, and start to think about analysis, visualization, decision-making, and that sort of thing. So it brings us towards this kind of common understanding and collaborative atmosphere. So with all that background, I'm going to pivot and talk a little bit about how some of this might be useful or serve as an inspiration for folks in the room. So a couple of months ago, Ollie reached out over LinkedIn and sent a message saying he'd come across a conference presentation that we'd done, and he was kind of interested in the work. And I looked up platform, and at first I was confused and wondered if this was some sort of spam. And then I took a look at the website, and I saw all these lines looking very similar to city streets, and it started to make sense. And Ollie shared with me this visual representation of kind of the data model that's happening in a vineyard where you have rows and vines. And it kind of clicked where what's happening in a vineyard looks really, really similar to a cityscape. It's just that instead of streets and buildings, you have mid-rows, vines, fence posts. And so what that means is that I suspect that you'll probably run into similar challenges with mapping and geographic data but also you may be in a place where you can leverage some of the same solutions coming from other industries like transportation. So one of the problems that Ollie talked to me about is that, if he needs to mark the location of something that's been broken, often the best way to do it is to just walk to the end of the row, tie a piece of flagging tape on the fence post, and hope somebody is able to figure out what he was trying to mark earlier. And so a question he had is, well, are there ways that technology could help with this? We're all walking around with phones in our pocket. Surely there's a better way to do this, a more efficient way. And so the answer to that is it's sort of. So yes, there's ways that we can use phones. There's ways that you could build an app to kind of say, I want to report something that's broken and drop a dot. But you're going to run into some of the same problems with how we represent geographic data. So in this example, let's say I'm the blue dot, I'm walking along, I want to mark something broken. The problem here is latitude and longitude, really. It's that the accuracy of GPS on a standard smartphone in your pocket is 5 meters, and that's 5 meters on average. So it could be much better, but it also could be much worse. So I get this kind of zone of uncertainty, roughly 5 meters around. And what that means is that when I drop that point, it might end up in the right row, but it could end up 2 or 3 rows off in either direction, depending on my GPS signal. And so if somebody wants to go back and find it and it's 3 rows off, it's actually less helpful than if they just tied the piece of flagging tape on the post in the first place. And that's because what's going on in a vineyard is it's really critical to be able to reference the location of things with regards to those rows. So a different way that you could think about this is if we can kind of refer back to those rows. So if you can create a base map, start to draw in these rows and refer to location in a slightly different way. So let's say I'm here, I see the broken drip line. I could instead say I'm in row 2 at 30 meters along. And that's going to give somebody a much more useful set of information. It's probably very similar to how you might describe it to somebody, but there's ways that we can tell computers this in an automated way. So what we work with behind the scenes on the back end of all of our software is something called linear referencing, which is just kind of a fancy way of saying that we're referring to the location along a line. So that same model of row 2, 30 meters along on the left side, but I'm able to communicate that with a digital ID for that row and start to build on top of it. Once you can do that and refer to location in a consistent way, you can also build on top of it. The same idea as we worked on a curb standard, you could do that for a vineyard where you could agree on a common way to describe the vines themselves. You could agree on ways to report damage, to describe activity that's happening along the vine, yields and performance. It might be information that, that vineyards are keeping anyway, but you can start to tie it back to actual map data. And that means that people can come along and build different tools on top of it that you could put your data into instead of kind of reinventing the wheel or instead of having to tie this flagging tape over and over again. So those are the sort of concepts that I wanted to share with you. I also wanted to talk about, I wanted to give you a little bit more than just diagrams and ideas. I took some open tools that some of which we built, some that other people built, and I kind of tried to experiment with going out to a vineyard to actually do this mapping just to see what would happen. So there is one vineyard, exactly one vineyard anywhere near me, and they were happy for me to come and get some imagery. So the first step here was trying to create a base map where I could start to draw in those rows. And there's a bunch of ways to do this. You could use satellite imagery that's already available if the resolution is good enough. Sometimes in transportation, sometimes people put cameras on cars and drive the streets. You could do that on a tractor. There's special apps. I happen to have a drone and I wanted something high resolution. So I went out and I flew the drone over this vineyard. Took about 15 minutes and it gathered, I want to say about 1,000 photos. And then I had to take those photos and stitch them all together. I used some open tools to do this, a couple of software packages called Open Drone Map and Open Aerial Map. So one of them turns it into a little mosaic, and then Open Aerial Map is a place where I can put that out on the internet and host it so that I could pull that down from it in other places. So then I've got the image, and now I just have to kind of create that map data. And to do that, I use something called OpenStreetMap. If people aren't familiar with that, imagine Google, but you can actually go in and edit what's in there. So OpenStreetMap is a crowdsourced global map. It's got a fantastic amount of data. And it's stuff that people from all around the world have been contributing to. And I'll actually show you how I did this. So this is really easy. It doesn't require any sort of background in mapping or GIS. I just zoom in to the area that I want to work on. I'm going to hit edit. Hopefully this works. Great. And so I can see, here's the vineyard. You can see I've drawn in most of the lines. Got this imagery. I'm going to switch over to the custom drone imagery that I collected, which is a little bit more high resolution. And then literally all I'm going to do is say, I want to draw a line. It starts here, it ends here, and that's it. And you can start to have ways that you add more detail on top. Right now, the best I can do is call it a tree row. But if I wanted to put in more information about the grapes when they were planted, that's the kind of thing that you can absolutely put in here. Or you can keep it private and just say, here's a tree row and leave it at that. So I just do that, I hit save, and that is part of the global database. So that's how that works. So I went through and I created this data. And then the next step was trying to think about building the linear referencing on the back end. This is not something that is especially compelling to show visually, but I'll do my best. So I've pulled this information into GIS and I ran it through all of the linear referencing tools that we created for streets. So this is what assigns those global IDs that are useful for building on top of. And so all I'm going to show you is that there's a bunch of what looks like gobbledygook here, but actually is meaningful information to build on top of. And that means that once that linear referencing is done, I can start to use tools for transportation. So earlier I mentioned that one of the programs we did was take a bunch of GPS noise and turn it into kind of useful street information. So a representation of that is, let's say I've got a bunch of GPS noise that my tractors have collected over the year. So I want to be able to say where they've gone and where they've applied fertilizer, and I have all of this location data off of a phone. That's not super useful. I can kind of see some hotspots, but I could actually start to tie that to the rows of vines themselves. So snap those points to the lines and start to gather information about exactly how many passes have taken place. So in here, red is more, but we actually have numbers behind it. Yellow is less, etc. So you can start to repurpose those tools. Another thing I've got for you is in real time, if anyone wants to play around with this, I also gave the example of, let's say I want to use an app to record something that's broken so that someone can go back and find it later. So I can do the same thing too, where if I drop a point on here, this API will automatically snap it to the nearest row and get some information about that. So instead of just kind of being anywhere within the circle and not really being sure, I can actually snap it to that exact row. Because this is an API, it's something that people can build phone apps and other tools off of. They can customize it, repurpose it, etc. Same thing if I am kind of moving down and I want to be able to say this whole section has something that I want to report. I can start to draw my way down here. And again, instead of getting a collection of points, I've got this blue line and I can say, okay, here's the reference for the row. I started at 40 meters, it ended at 56. So this is something that just people can build on top of and start to think about, how do you customize this, or how does this become part of a stack of something that's useful for your own work? Flipping back over here. So that's most of what I wanted to be able to share with you today. I've got some links in here if anyone wants to play around with that. Where I kind of wanted to leave you is that, I mean, first of all, it's fantastic to have so many people in a room that are really excited to think about data models and mapping for vineyards and where you could start. Hopefully, I've shown you that the way that we map things is really important. And it can sometimes be tricky, but there's approaches from other industries like transportation that might act as an inspiration for all of you as you think about what's next. Maybe they're useful, maybe they get you thinking, maybe you go another direction, But hopefully it gives you kind of a place to start and a few ideas to bat around as you do this work. Also, kind of the beauty of so many of these map tools, not just ours, but a lot of geographic tools are open source, they're free to use, they're available to repurpose. And that's fantastic because it means that no matter which direction you go, you probably won't have to reinvent the wheel from scratch. You can kind of work with and augment what already exists. So there's ways to start with this today and borrow tools, try them out, see what fits, see what doesn't. You know, you could get started mapping a vineyard with OpenStreetMap today. You could do it yourself. People even have events called mapathons where they'll get together and work on projects like this. Yeah, so I'm really excited to see where you go from here and what's next. And I really appreciate the opportunity to share this work with you.
Thanks so much, Emily. That was really fantastic. Paul from Capital Codes has been working with us, and he was the one that suggested Emily's presentation and that we could think about vineyards like streets and look at the work on curbs. And after that presentation, I'm really convinced by that, and it's really exciting to just that you understood that for us, Emily, and you understood the potential, and thank you so much for your effort and energy. We've got time for a few questions, a couple of questions. Do we have any? Well, yep, we can save them all for the end. Okay, that's great. So I'll hand over to Fiona from Bitwise.
Okay, I'll just set up my screen. All right, can everyone see my screen? And hear me? Yep, nods, perfect. Awesome. Well, hi everyone. Great to see such an awesome turnout at this event online and in the audience there. So thanks everyone for coming. It's a great thing to see that everyone's as passionate about location intelligence. So I'm Fiona Turner, sometimes known as Fiona Duncan, before I was married. Yeah, I own a company called Bitwise Agronomy, and we do automated crop analysis, but spatial intelligence is really important for what we do because like Emily, I've come from a spatial background. I've worked with councils and smart cities and water networks and things like that. And for me, I see things in a spatial way. Every asset is just, you know, everything is an asset and it's got a location. So I want to be able to bring all that together so we can get more value in how we farm and grow. So let me just move on. So basically what Bitwise Agronomy do, you know, I have a vineyard myself. I was like, whoa, it cost me like 10 grand a hectare to grow grapes. How do I do that cheaper? I was traveling a lot for work. I was like, I can't see what's going on in my vines. I was coming home and they were out of control and I hadn't done the right jobs at the right time. So I was like, okay, how do we solve this problem? And, you know, how do I get, without having really, really expensive, high quality staff to look at my vineyard all the time, how am I going to do this myself? So Bitwise was really born out of that. And basically what we do is we use commodity cameras like GoPros, and we use the GoPros because it's got a GPS component to it and we want to know the location of what we're looking at. And we do things like this. We look at the vines, we go through, we use spatial information about them to then identify what vines what and what's on that vine. So what can we do with this data and why is it important? So I'll just move to the next slide. All right, so we take this information and we put it into actionable insight and into reports. So you can see here at the top of this report here, I can see as I go down a row in my vineyard, I can see different things that are happening. I can see the number of canes per vine and the number of nodes per that, which is really important to me at the moment because I'm looking at my pruning weights. And this textual information up here, you know, I can sort of break it down to see my pruning quality. Now, quite embarrassed to say that this is a row that I pruned myself. Obviously, I'm way better at technology than pruning because this is all meant to be 4 canes and there's not 1 4 cane for the vine there. And look, as you go down and I overlay this on a map, I can do different things. I can take the same data that we saw in that video and I can do different symbology for the number of canes laid down, and then I can correlate that with the number of nodes per those vines as well. So you can see in here, there's sort of a gap. There's no circle in between these two circles, if you can see my, my mouse there, and that's because there was, I probably messed something up and there was no canes to tie down there. So, you know, all of a sudden, by putting this textual data into a spatial context, I can make, you know, decisions. I can follow up on pruning techniques, the quality of the pruners that I have out there, and I can start making real time and real actionable changes to how I'm farming, because, you know, a picture says 1,000 words. So what I did to, just out of interest, to look at my pruning quality compared to my neighbours, I looked at my neighbour's property here. Now, this is probably what you'd want to be seeing with your pruning quality. You can see here, this is all 2 canes, very consistent. The green box, which is the number of nodes, are very consistent along this as well. So yeah, my neighbour's pruners are way better than me. So that's great. So he can start to calculate now what he's thinking about the yield, and maybe there's some issues over here where they've got lots of like little baby vines that, you know, aren't going to get much yield from this year. So other things that we've been doing is that we've been looking at growth heights as well, and mapping that back to different rows in different areas in the vineyard. So again, using your GoPro camera with GPS on it, we can go through and we can look at how the canopy is growing throughout the growth season. So when I look at the reporting for this, I can report over time, I can overlay this in a map over time, but I found something really interesting. So I had a gut feel about this anyway, but I just didn't know that it was so drastic. So as I was driving up this row here with my GoPro camera, I noticed that down the bottom, my crop is always a lot more vigorous than at the top. And that's quite clearly shown in this chart here, and also in the colours of the points on the map. Now, why are standards important, and why are we sort of on this collaboculture journey, and why am I so passionate about it? Because by looking at this map, you'll see some errors in it. When I look at the charts over here, it's moving from left to right. When I look over here, it's moving from right to left. Easy mistake to make, but without that sort of standards of how we organize our data and how we set up our assets, this could be really confusing. If I just had the chart, I would assume that that was going down my rows, not up my rows. Now, what if I was to then take information from Ollie's platform system, and I was getting information from his tractor, which was actually driving down the row? And what side do I snap that data to? To the left-hand side of the row, to the right-hand side of the row? And all of a sudden, we start to get this inaccuracy of the data, and that 5 metre sort of radius that Emily talked about around how accurate the GPS signal becomes really, really important. So standards and database structure are inherently important. So for me, working in GIS in the past, you know, I've seen that most other industries do spatial analytics. You know, we talked about the roads. Here's an example of the rail network. There are standard ways that we're used to seeing spatial problems and spatial information. Up here, we've got solar farm in WA, which has, you know, different power grids and contours and stuff, all standardized by the industry with the look and feel. We've got road networks that are standardized with standardized databases. We've got soil maps that, again, standardized with standardized databases. So how do we apply that learning and bring that into the agricultural world, in particular the viticulture world, so we can get the most out of our crops? So a fair while ago, the Penn State University in America came up with this phrase: the location of anything has become everything. And this happened because in 2007, the iPhones were released, and everyone could take a GPS coordinate of everything, which we hadn't really been able to do until then. You know, you had your handheld GPS devices, you had surveys out there, but not everyone just walking around was collecting this sort of background GPS and GIS data. And then in 2010, Google Maps were released, and those two technologies came together, and everyone wanted to know, where am I at, what's happening here? So in vineyards, we really need to look at some of these other industries that have done this before. And one of my pet hates is this asset management mess. So if we look at utilities, water, oil, mining, and you go into their asset databases, there's never, well, not never, I shouldn't say never, that's a bit rough. Quite often the data doesn't match up. They have different IDs for the same asset, depending on what system you're looking at. So we've got an opportunity here to really look at our data and look at what level of the asset hierarchy that we want a vineyard to represent, and set that up correctly and set it up in a consistent way. So all of these ag tech companies and all of these mapping companies, when they come onto your property, they come on to have a look at your crop, we've got a similar standard, so all this information can come together from different sources and give us a lot of power. So what we do is we have what we call our organisational breakdown structure. It's a pretty loose asset hierarchy for vineyards. We look at the owner, the company, then we go down to the next level, which is the site, go to the next level, which is the block, the next level, which is the row, and the next level, which is the plant. And like linear referencing, then you've got an ID that flows all the way down to that granular level of each plant. Then imagine underneath that, you can say, well, this irrigation pipe overlaps with this row, or these grapes or this wine that came from this block was of this quality, and let's go back and have a look at the data to see what the growing season was like. The possibilities become endless. So for me, out of this whole spatial journey that we're on with collaboraculture, the greatest things that I think can come out of this is some kind of standardized GIS database, then schema of data that we can all adhere to, and that all of us, I suppose ag tech companies have a responsibility to adhere to, and also some kind of standardized map template. The symbology needs to be the same and consistent across all of us as well, because you as growers and farmers and winemakers, you don't want to become GIS experts. You want to be able to look at my data and know exactly what you're looking at, look at data from platform, know exactly what you're looking at, and know you're looking at the same things, not the same things, you know, symbolized differently. So that's pretty much everything that I had. I'm really passionate about this and happy to talk to anyone who has an interest or any questions. So thanks for your time.
Thanks so much, Fiona. Such great practical application and context for us. So that's quite the big challenge of how we pull that all together and create these standards. Luckily, we have John Byant here, who's going to tell us exactly how we do it in a matter of 5 more workshops. So thank you, John.
Okay, that's a tall order, but let's see what I can do here. Just share my screen. Okay, is that looking all right? Yep, okay. All right, hi everybody. My name is John Byant. I'm an open geospatial specialist with Mammoth Geospatial, focused on open source. And I'm involved with open geospatial community building in Australia and internationally. So my role with the Collaboraculture project, I've been working on identifying the data issues facing the viticulture community through conversations with people in various roles, such as agronomists, vineyard manager, head of technical services, Viditech startups, and biosecurity, to get multiple perspectives on how they deal with data and what are the problems they face, what are the shortcomings of the status quo. So what came up in those conversations, one of the things that came up was the key reasons why we actually need a data model. So the first one that really jumped out was the need to improve the situation with regard to data portability and interoperability. We need the ability to use the available data that we have in the systems of our choice. So if we're GIS operators, we want to be able to get the data that exists and bring it into our own systems. And second, we need to get these all the systems that we use to talk to each other. So a common problem that was identified was that there are a multitude of different systems that we use, and they don't necessarily interoperate very well. They don't necessarily communicate very well. And the idea is that having a standardized data model will help grease the wheels of that interchange. Second point that jumped out was a benefit of building a data model would be building some consensus among the community. By working through the development of the model as a community, we can come up with some agreement on some of the building blocks, nomenclature, for example. You know, what are things called? We can find some agreement on some of the details. Third item, support technical practitioners. If we can help remove some of the obstacles of upgrading systems, if you're building out a database, for example, having a standard data model in hand can help you do this more easily and with confidence. And the last point here is digital literacy. And a few people mentioned that a general uplift in technical knowledge would benefit the whole community broadly. So,
sorry to interrupt. Have you got two screens?
Have I got two screens?
Yeah, I think we're seeing the wrong. Are we seeing the? Have you got two screens?
I don't know what you're saying.
Oh, I think we're seeing the wrong screen.
Okay, hang on.
You want to press present, John? It's literally just press present.
Press present.
Press present.
Sorry.
Yep.
Big yellow one.
Okay, my apologies.
No, that's okay. That was our fault. I think we didn't see the dot points if you were going through that slide. Perfect. Thank you. Sorry.
Better? Okay.
Yep.
Sorry about that. Anyway, those are the 4 points there, but let's move on. So what a data model could actually look like? These are detailed in a little bit more detail in the discussion paper, but this is one possible approach. And what we're looking at here is the concept of a conceptual model and a logical model. So a conceptual model is where we identify what are the building blocks that make up a vineyard and a grape growing operation. And this is what we're looking at here is this sort of standard vineyard block row concept that a number of people mentioned. But to build out the conceptual model, I think would be an exercise where we work through what are the actual building blocks. These are the basics, but it can be extended quite broadly. And what are the relationships between these building blocks? So once we have a conceptual model, we could then elaborate on that conceptual model and create a more detailed logical model where we take those building blocks and actually flesh them out. Describe attributes. So the picture I've got on the screen here isn't necessarily actually like this is supplier delivery, but I think what we'd actually see is, you know, the vineyard, the block, the row, et cetera, and what are the attributes that define those things. So for a row, for example, you might have the variety that's planted, the date it was planted, things like that. And then provide some structure on how you actually describe those things. So what are the data types? What are the possible choices you can make for those attributes? So there are a number of other possibilities beyond the conceptual and logical models, such as those raised by Emily and Fiona and others. We could have agreed standards on capturing things like time, precision, and accuracy, unique identifiers for objects. So with regard to precision, for example, you may have geographic coordinates for the endposts of your vine row, but are they precise to plus or minus 10 meters, 3 meters, or 3 centimeters? This could affect whether you can send a self-driving machine down the row. having a standard for precision can help make sure this is captured properly. We could look at a linear referencing model for vine row infrastructure, as Emily described in some detail. We could look at standard data formats and interchange protocols to make it easier for systems to talk to each other. Integration with freely available open data sources like OpenStreetMap. And then technical implementations for specific technologies like QGIS or ArcGIS if you're using a desktop GIS system, or databases like PostgreSQL or SQL Server. So the next steps for this project, as I understand them, are one of the first things that we've been talking about working on is to do that conceptual model, to collectively identify the features of vineyards that could be part of that initial data model. And I think that'll be the subject of an upcoming workshop. We can, once we actually have something pinned down, we can present it back to the group, present that draft model and get some feedback. We can work through reaching consensus on what should be included in the initial data model. That'll be the outcome of this project. And then once we have something, we can publish it online and make it available for people to use. And I imagine that would probably be subject to more feedback and improvement over time. So I think that is about all I've got, Lindsay.
Excellent. Thanks so much. Thanks for giving us that context, John. And I think that will help everyone to understand why this is a bit of a journey and why there's a lot of work that we all kind of need to do together and why we're splitting this up into workshops. It's not simple stuff and everyone's coming at it from a slightly different perspective. And so we really appreciate everyone's time and involvement in making sure that we get as many people and perspectives together, because this has the potential to be something that can be adopted really broadly. So getting it right is really critical. We've got time for questions. So we've either got questions coming from online, but also on the floor. If it's on the floor, can you just wait until the microphone's in your face? And feel free to direct questions to any of our speakers as well. Any from the floor?
First, just going over to Seb from Gaia.
G'day all. Sebastian here from representing Gaia. So I actually have a question for Emily on your experience with open data and open source business models. So at Gaia, we've mapped all of Australia's vineyards and we have vine rows for all of Australia. I just wanted to understand what your experience has been in like successful open source and open data business models.
Let me unmute. That's a great question. So the reason open source is tricky to fund because often people want to fund something new. And then when you want to maintain it over time, it becomes less exciting. It's the same thing we see where everybody wants to ribbon cut on a new street, but to try to get them to fix a pothole is much more difficult. But I think around geographic data, there have been successful, I mean, OpenStreetMap is one phenomenal example of something that is open source, open data, maintained by a ton of contributors, does have commercial support, but has been able to endure over time. And a lot of the tools that are built on top of OpenStreetMap are the same. But then there's other cases where if someone builds open source software and then they walk away, you know, that's something where somebody has to either come in and maintain it or it languishes. It doesn't come with the same enduring promise of commitment that you may get with a private company or a contract.
Yeah, thanks.
Brilliant. Any other questions from the floor?
Got a question online from Adam, a question for Emily. Do you have an automatic method for associating the same curb segments between different data sets, or are the associations made manually?
Yeah, I've got a slide for that actually. So yes, so often what we run into is that every city, every map provider has their own understanding of exactly where their streets are. And that's fine. We're not trying to get everybody to kind of map things the exact same way. nor would we ever be able to get them to, but we do want to be able to refer to them. So the way our linear referencing model works, which I should say is inspired by OpenLR, which is something that TomTom created. What we do is we say, the exact coordinates of a street don't actually matter. What matters is the start point, the end point, and the bearing. And so the linear referencing model that we use will take those pieces of information and assign an ID, which is a 128-bit hash. It's a series of letters and numbers that look random and are unique, but actually do encode the geographic properties. You can take any street that is similar enough and it will be matched to that same ID. So nobody needs to change. They can all just kind of take what they've got and then add this ID as an extra property that will be able to link between maps. So that way we can take curb segments from one city, attach this identifier to it, and then somebody with a different map would be able to do the same thing.
Excellent. Emma Leonard is offering to organise a mapathon for ag, if I read this comment correctly. But seriously, we do want to be able to take some practical examples at the end of these workshops as a bit of a where to from here. And having mapathons, whether it's for viticulture or a bit broader, is absolutely something that comes up as a suggestion. Really great for capacity building, working through some of these digital literacy issues that we're hearing about as well. So a really good suggestion to hold on to as something we might be able to do in the future. Adam has a question for Fiona, about another one. So Fiona, does OBS data structure allow for representing changes to the vineyard over time?
Yeah, so how we are looking at our OBS, because it goes down to the vine and the vine's given an ID. If a vine changes, dies, something else gets put into its place, you could represent that as a child of that location, or another vine in the same location, and would archive or deactivate, I suppose, the vine that was there beforehand. Because we're running the imagery consistently, we will see, growth, and growth can be added in terms of new sections of the vineyard. So yeah, it's really important to reflect changes over time and keep that parent-child relationship of what's happened in that location.
Excellent, thanks. And before Martha pops off, she had a question. What about using RFID identifiers for rows? They've been now incorporating those identifiers for each row in their vineyard with great success. Fiona, is that a question for you?
Yeah, look, I can answer that. There's been some really good improvements with RFID technology. I was doing some work in the oyster industry where we were looking at mini oyster cages along a row in the water. Same problem, right? Oyster cages can be the same as vines down a row. And there's new technology that allows you to see one-to-many RFID tags and read that all in at once, and then sort of cluster those together so you get an accurate reading of where that RFID tag is. So there's definitely use for that type of technology. If you, I suppose the hard thing is that are there apps out there, or are there systems out there that can take that information and do something with it that's smart? And then that sort of refers back to, well, your RFID tags will have a spatial location. You're getting some information from that. How does that map? How do you look at that in terms of spatially and get some spatial benefit out of it as well? But it's one of sort of many sensor-based and transmission-based technologies that could be used.
Excellent, thanks. Emily was talking about the accuracy of mobile phones, and Emma makes a great point. I guess considering a lot of us in the room have tried to work through these issues already, that for about 4,000, she's been able to add an antenna to her phone to make location within 2 centimetres of accuracy. So don't let this be a sticking point for us. And talking through and sharing the ways that you work through some of these challenges is very much a part of the discussion that we'd like to create through this process. And I guess touching on that, Andrew's made the point that Agritech New Zealand is doing stuff, and have we linked into them? We've done a pretty extensive look at who's around. We've had a bunch of conversations, but absolutely, especially if people know of some key people that are very worth talking to, and then we can invite them into these workshops, because the format of them will kind of evolve as we start start to unpick this. So thanks, Andrew, and we'll definitely be in touch with them. Or have you already?
I can probably just mention quickly to Andrew as well, if he's listening. We've put, because PERSA have helped us to put these on, and Adelaide is a part of the Great Wine Capitals Network of the world. So they've shared all these workshops out across that network. And the idea is very much that we don't do something in isolation in Australia, that we're doing stuff that is working with global data standards, and we do something that literally can work anywhere. So that's absolutely our intention. But yeah, so please do sort of share the URL and help people to join. And we'd love this to ultimately, if it can end up with Emily doing this in Napa and Sonoma, and yeah, this would be fab.
Excellent. From Joe, it's clear that an open source vineyard tree row model would be valuable in the future. What about the plans around who authors it? Is it a single point of truth managed and maintained by one company, or crowdsource where individuals contribute and maintain the model for their particular site? Vineyard infrastructure does change over time. I think that's a great one for you, John.
I think that's a great question. One thing that I think we could learn from the open source community is that software projects are often run by a group of maintainers using like something, and transparency is sort of key to that. So using something like a GitHub repository where you actually keep your code and the discussion around how that code evolves in a public place where people can participate in the conversation. And I think it just keeps everybody accountable, and also leaves the opportunity for people to sort of watch and then join in and participate as time goes by, once they sort of understand how the community works. So it's a suggestion, I suppose, for me, that I think that's a great model to follow for a community project.
Thanks. So there's a question on, is there a list of data types, data growers, viticulturalists that people would find useful on a map? What we've been doing on the collaboraculture.com website is adding all sorts of resources. So most of them relate to the viticulture industry, but if there's stuff around open data, standards that might be applied in agriculture and other areas as well. So that's really intended to be a place that between workshops that there's either resource sharing or discussion. So if anyone has either resources or questions about resources that they want to put up, take a look there and see what's there, but also make suggestions as well. And from Jason, will external data sources like rainfall, geology, and data captured from IoT sensors be part of this data model? I think the answer to that is generally yes, because those are the things that we want to then map against that infrastructure. How deep we go into some of that stuff will depend on how much time we have over the course of these workshops, but absolutely talking about that online and collecting information around it. It might be part of a where to from here after this series to say, okay, now we've defined the thing, how do we put more stuff onto it? So that's a really good question.
Hello, Giacomo from CSRO. Probably this is a question more for Vineyard Manager, but I would like to know an opinion from everybody. We talk a lot about GPS precision and the problem associated with that, and all the time and effort